Good morning, children. Let us do some problems of trigonometry today. These are all actually solved examples in your textbook, but I will just solve it for you. Question number 2. If angle B and angle Q are acute angles such that sin B equal to sin Q, then prove that angle B is equal to angle Q. So here actually figures are not given. So this figure we have to draw. So let us take two right angle triangles. This angle B and angle Q are acute angles. It may not be of the same triangle. So we have taken two right angled triangles, and angle B and angle Q are acute angles, as you can see in the figure. So here what is given is sin B is equal to sin Q. So what is sin B? Sin B in the first figure is the opposite side, that is AC divided by AB, and sin Q is equal to PR divided by PQ. So from these two, let us call it number 1 and 2. From 1 and 2, we can write AC by AB is equal to PR by PQ. Correct? Yes. Now we will bring this PR to left side and AB to right side. That we can do. AC divided by PR is equal to AB divided by PQ. That means these two ratios are equal. Let us call it some K. We used to write a word called say. Say means let us assume that these equal ratios are equal to K. Therefore, what is AC? AC is equal to AC by PR is equal to K. Therefore, AC is equal to K into PR, and AB is equal to K into PQ. Now we shall find BC. BC is equal to, using our Pythagoras theorem, BC square is equal to AB square minus AC square. So BC is equal to square root of AB square minus AC square, which is equal to square root of, what is AB? We have a KPQ. KPQ whole square minus AC is AC is KPR. KPR, K means K into PR whole square. So this is equal to square root of K square PQ square minus K square. Sorry, first one I made a mistake. Second one, AC is equal to K into PR. Okay, PR. Please understand. So here K square is a common factor. So K square into PQ square minus PR square. I hope all of you understood. I just avoided one step. So this is equal to, inside the radical sign there are two factors. One is K square and the other is PQ square minus PR square. This K square, we know square root is K. So it becomes K square root of PQ square minus PR square. Let it be there like that. Now we shall find QR. Excuse me. QR is equal to, by Pythagoras theorem again, it is PQ square minus PR square. Therefore, BC by QR is equal to, what was BC? K into square root of PQ square minus PR square divided by QR is a square root of PQ square minus PR square. So here this entire radical sign, that is like a bracket only, that can be cancelled. So what remains is a K. So here you come back, let us call it 3. This is 3, this is 4. So from 3 and 4, this is K, this is also K. So we can write AC by PR is equal to AB by PQ, which is again equal to BC by QR. See, in these two triangles, all the 3 pairs of sides are proportional, or we can say the ratio of 3 pairs of corresponding sides of these two triangles are equal. What does it mean? That means triangle ABC is similar to triangle PQR by using SSS similarity criterion. So if these two triangles are similar, what can you say about the angles? Therefore, angle B is equal to angle Q, because we know corresponding angles of similar triangles are equal. So now I hope you have understood the method of proof. It looks difficult, but you should have that idea how to do it. See, from the given ratio sin B is equal to sin Q, we get 2 pairs of sides proportional in these two triangles. But that is not enough to prove the similarity of these two triangles. See, our aim is to prove angle B is equal to angle Q. So if we can prove that this triangle is similar to this triangle, then our work is over. Then the question is how to prove. So from the statement what is given to us, we can get 2 pairs of sides proportional. And if suppose we were given angle A is equal to angle P, then by SAS we could write these two triangles are similar. But that is not given. So we did all these steps. Our aim is to just to prove that the third pair of sides are also proportional. So we proved BC by QR is also equal to K. So we got all the 3 pairs of sides proportional. So we can say these two triangles are similar, and we got angle B is equal to angle Q. Now let us do question number 3, example 3. Consider triangle ACB, right angle at C, in which AB is equal to 29, B is equal to 21, and angle ABC equal to theta. Somebody asked about the theta. Theta is a Greek letter which is usually used to represent measures of angles in mathematics, especially in trigonometry. Now determine the values of cos square theta plus sin square theta to cos square theta minus sin square theta. So before that, let me just tell you what is cos square theta. I have told you, I think, I don't know. Cos theta, square of cos theta. We can't write like this. We can't write like this. This is wrong. But the cos theta, the square of cos theta should be written like this. Cos square theta. This is the correct method. Okay. This is a wrong method. So whenever a square of a trigonometric ratio comes, we should write that square between that ratio and the angle. And how to read it? Cos square theta. Its meaning is square of cos theta. Okay, now let us come here. So 2 sides are given, AB and BC. So let us find AC. Here they have already done. Our work is just to complete it. So square root of 29 square is how much? 841, I think. Minus this is 441. All these squares you should be remembering by heart. Okay, it will help us a lot. It is 400 equal to 20. So this is 20. So all the students are requested to remember the squares up to 1000 at least. 1000, that is 31 square. 30 square is 900. 31 square 961. 32 square is more than 1000, that is 1024. So at least up to 1000 all the perfect squares, and if possible perfect cubes also. Please remember by heart. It will save a lot of time. Sometimes what happens in examination time, when you find the square of 29, we may make a mistake also while multiplying, but if you know by heart, you need not multiply, directly you can write. Okay, now let us do question number 1. Cos square theta plus sin square theta we have to find out. So for that, let us find cos theta first. Cos theta is equal to, what is the definition of cos theta? Adjacent side, that is BC divided by AB, that is equal to 21 divided by 29. Now let us find the sin theta also. Sin theta is equal to AC divided by AB, that is 20 divided by 29. Therefore, cos square theta plus sin square theta is equal to 21 by 29 whole square plus 20 by 29 whole square, which is equal to 441 by 841 plus 400 divided by 841. So here denominators are same, so we can just add the numerator. There you will get 841 divided by 841, that is equal to 1. So first step, we got the answer. Cos square theta plus sin square theta is equal to 1. Now let us find cos square theta minus sin square theta. Cos square theta minus sin square theta is equal to, what was cos square theta? It was 21 by 29. 21 by 29 whole square minus 20 by 29 whole square. So here also this is a 441 by 841 minus 400 by 841. This is equal to, if you subtract, it is 41 by 841. So okay, next question. In a right triangle ABC, right angle at B, if tan A is equal to 1, then verify that 2 sin A cos A. 2 sin A cos A means 2 into sin A into cos A is equal to 1. So in triangle ABC, tan A is equal to, tan A, we are taking this angle, tan A is equal to BC divided by AB, that is equal to 1. BC divided by AB equal to 1 means BC and AB are equal. So BC is equal to AB. BC equal to AB. BC equal to AB. Let us call it K centimeter. Now let us find AC by using Pythagoras theorem. AC square is equal to AB square plus BC square. What is AB square? This is equal to K square plus K square, that is equal to 2K square. Therefore AC is equal to square root of 2 into K. or we can say k into root 2. This is k, this is also k. Now we have to prove this result. So let us find sin A. Sin A is equal to what is sin A? Opposite side by hypotenuse, that is BC divided by AC, which is equal to k divided by k root 2, which is equal to k cancelled, it is 1 by root 2. Similarly, now let us find cos A is equal to, cos A is adjacent AB divided by AC, that is k divided by k root 2, that is also equal to 1 by root 2. Now let us take our LHS. LHS means left hand side of what is to be proved. LHS is equal to, or we can, okay, 2 sin A cos A. Don't write equal to 1, we have to get 1. So this is equal to 2 into sin A is how much? 1 by root 2 into cos A is also 1 by root 2. So you get a numerator, when you multiply 2 into 1 into 1, that is 2 divided by root 2 into root 2, that is 2. So 2 by 2, we got a 1, which is RHS. So we got a LHS is equal to RHS. That means proved. This is the way to solve such problems. Let us do another problem. In triangle of PQ, right angled at P, OP is equal to 7 centimeter, and OQ minus PQ, OQ minus PQ is equal to 1 centimeter. That means the difference between hypotenuse and PQ is equal to 1 centimeter. Determine the values of sin Q and cos Q. Sin Q and cos Q. So here it is shown in triangle of PQ, it is a right angle triangle. OQ square is equal to OP square plus PQ square by Pythagoras theorem. So instead of OQ, we can write 1 plus PQ. See, OQ minus PQ is equal to 1. Therefore, OQ is equal to, if you carry PQ to that side, 1 plus PQ. That is what is written here, 1 plus PQ whole square is equal to OP square plus PQ square. This we are expanding using our A plus B whole square formula. A square plus B square plus 2AB, that is equal to OP square plus PQ square. So this PQ square can be cancelled from both sides. So 1 plus 2PQ is equal to, OP is given how much? 7. So we can write 7 square. Or we can say 2PQ is equal to, this is 49. 49 minus 1, 48. So PQ is equal to 24 centimeter. Okay. I hope all of you understood. This 2P, 1 plus 2PQ is equal to 49. So 2PQ is equal to 49 minus 1, that is 48. So PQ is equal to 24. So we got it 24. This was already given 7 centimeter. Now OQ is equal to, here OQ is there, 1 plus PQ. So it is 25 centimeter. So we got all the three sides. Now we can find out sin Q and cos Q. Therefore sin Q is equal to, what is sin Q? Opposite side. What is opposite side? OP divided by hypotenuse, OQ. That is OP, that is 7 divided by 25. Similarly, cos Q is equal to adjacent, that is PQ divided by OQ, which is equal to 24 divided by 25. See, when you do all these problems, we will become very thorough with the definition of these trigonometric ratios. Many times we are taking opposite side, adjacent side, hypotenuse, all those things. So without writing the name of those sides, it will just come automatically. So children, this much only. These are the solved problems of the textbook. You can also refer the textbook. Now I would like to give you the remaining problems of exercise 8.1. We have done up to question number 5. Questions 6 to 11 we have to do. 11th one is actually true false question, but it is important. The other problems you can try. I will give the solution, but first you have to make a try. Trigonometry is actually very interesting. Those who get the strong base, see, those who have understood the basics of trigonometry, it is very easy also, very interesting also. So I hope nobody should be left out from learning this trigonometry chapter. And we have got a second chapter also, application of trigonometry. The coming days are very important, so let us be thorough with these basics. So here I stop. So thank you children, have a nice day.